Hi everyone, in this video let us go through the lab for the shared VPC on Amazon EKS. In the earlier video we discussed the concepts, the benefits, why shared VPC on Amazon EKS and what are the various benefits. In this video let us implement how shared VPC works on Amazon EKS clusters. Let's get started. These are the lab instructions. If you see, we have some bash commands alias to set the shortcut for various Terraform commands. For example, TV stands for Terraform version, TI stands for Terraform init, TP is Terraform plan, and TA is Terraform apply. Similarly, TAA is Terraform apply auto approve. This makes easy when we run the commands. So this is the setup environment section. The next one is setup cross account access. So we need to configure this file called config file in the .aws folder in the home directory. This is for setting up the delegated access to different accounts. So for example, let us look at the contents of this file .aws/config file. So let us do a cat on this file. So here we have two profiles, cross dev account 1 and cross dev account 2. So in the first profile, cross dev account 1, the role ARN is the cross account role. This is IAM role in the account starting with 4054. This is one account. And similarly for profile cross dev account 2, we have the similar IAM role but in a different account. So what exactly is happening here? So I mentioned IAM role and also I mentioned source profile JP. So there is one more profile called JP which contains the IAM user credentials. The IAM user credentials include the secret key and access key. These are the long-term credentials. So this particular IAM identity, which is the IAM user JP, is able to assume this role called cross account role in this account. Okay, similarly, the same IAM user, which is JP here, is able to assume a role in a different account. So that means by assuming the role in different account, we can perform the actions in the respective account. Okay, so this is what it is. So let us go back to the lab instructions and check few commands there. So the first command is AWS -- profile cross dev account 1 sts get caller identity. So let us run this. So if you see, we are running this command called sts get caller identity. It will tell you who is the IAM principal, who is assuming this role, right? So the IAM principal is the JP user is able to assume this role. So we are acting as if we are the IAM user called cross account role. Okay, so that means any actions from here onwards with this profile, these actions will be performed with the IAM permissions of this role in this account. Okay, so similarly, let us try the other command, which is cross dev account 2. So we can see that the same IAM user is able to assume a different role in different account. So let us go back to the AWS console for this account and see what are the resources available there. So this is the first account, the cross dev account 1. And here if you see in the VPC section, we don't have any new VPCs. The one VPC what you see here is a default VPC. Okay, so we have not created any VPC. This is the first account. Similarly, on the second account, if you go, there are no VPCs available here. This is a second account. So in this lab, what we'll be doing is we'll be creating a shared VPC in this account. So the shared VPC created in the second account 2 will be shared with the account 1, right? So that's the idea. And once the shared VPC is accessed from the account 1, we will be creating an EKS cluster in this account. So this is what the lab will be. So let's go back to the instructions. Now let's go to the directory. So I've already went to the directory. So this is the directory. Now let me run the Terraform init command. So when we do Terraform init, the Terraform modules and the providers will be initialized, and those are available in the versions.tf. So you can see we are using the latest Terraform 1.7.4 and pretty much latest versions for the remaining providers as well. For example, Kubernetes, AWS, and other providers. Okay. Now I will run Terraform plan, which is TP. It will take a while. Yeah. So if you see the Terraform plan, the cross dev account is this, and cross dev account 2 is this one, and the VPC which we'll be creating is in account 2, and with so and so the private subnets. We are creating multiple private subnets with the different CIDR blocks, and there is a public CIDR block as well, and this is my VPC CIDR block, and the name of the VPC is EK Shared VPC. So now let's go back to the source code and see how we have configured the Terraform to create the resources in both accounts. This is my main.ts. On this file, I have configured the multiple AWS providers. The first one is for this outbound environment where I'm running. I did not use any profile or alias here. Second one is for dev account 1, and the third one is for dev account 2. So I'll be using these profiles to create the resources. So if I go to my VPC module, I'm initializing some variables here. So some of the variables are private DP subnets, which is data plane subnets, and public subnets, and private control plane subnets. I'm using an algorithm to dynamically compute the CIDR range for the public and the private subnets. How this algorithm works, I'll discuss detail in a separate video. But for now, let's assume that this algorithm is configured properly to cut the VPC CIDR into multiple subnets CIDRs. In the module VPC, I'm using the provider class dev account 2. That means the VPC has to be created in the dev account 2. I'm using the latest Terraform module version for the VPC. If you go to the Terraform VPC registry, you will see that 5.5.2 is the latest at the time of recording this. So I'm creating private subnets and public subnets. In the private subnets, we have two types of subnets. One is the control plane subnet, another is the data plane subnets. When you create EKS clusters, it's always a good practice to allocate dedicated small private subnets with control plane and another dedicated subnets for the data plane where the pods and the nodes will be running. So the public subnets also you can create if you are having any ingress traffic from outside. Here I am providing some names to the private and public subnets. Enable NAT gateway true and single NAT gateway is true. So for this demo purpose, I am using only one NAT gateway. But for production workloads, we will always create one NAT gateway per using for high availability. Similarly, I am configuring the DNS options as well, disabling the VPC flow logs for this demo purpose. In the production, you should be able to enable it. And there are a few other network access control configuration I mentioned here. The tags are very important. I have added some tags for the public subnets and the private subnets. These tags will be used by the AWS load balancer controller when you provision the network or the network load balancers. If you are creating a public facing load balancers, public subnets will be used based upon the tags. Similarly, the private subnets.
I've also enabled certain tags for the content that we will discuss later. And for the default security group in this VPC, I just mentioned some ingress and egress rules. This is my VPC module. And I'm creating this in the last day account too. Then, before we go further, let us first understand a few more details about this module. So, net employees and variables. So, in this case, the VPC slider, the private data plane subnet slider, similarly the public slider block. Also, there's a private slider block. And in outputs, I'm just outputting the ARN of these subnets and also the slider blocks. But we will see when the Terraform completes execution. And in the Terraform.tf watts, you can see the initialization of these variables. The region is US East 1. Cluster name is ecase-shared-VPC. I'm using the same name for the VPC and the cluster. VPC slider block is 10.0.0./16. So this is the 65,000 IPs from this VPC. This is the max size that you can allocate to a VPC. So these are the sizes for the public, private, VP and the private control plane subnets. So for example, if I say the data plane size is /18, which means every subnet will have 15,000 IPs. And if you have 3 availability zones, that is 48,000 IPs you are allocating for the pods and the nodes. And the slider block for the public subnets is /24, which is 256 IPs. And with 3 availability zones, it will be around 784 IPs. And for the private control plane, which is CP slider block, which is /28, that means 16 IPs times 3, 48 IPs, which are more than enough for the control plane. So, depending upon the size of your VPC, you can decide the sizes accordingly. So, since I'm using the /16 slider size for the VPC, so I'm going for the maximum possible sizes. Okay. So, this is more about VPC configuration. Now, let us talk about sharing the VPC across accounts. So, in this file, I'm first enabling resource access manager service in my primary account, cross dev account 1. So, why I'm doing this here? In my AWS organizations, we have 2 accounts. One is the management account, another is the test account. The cross dev account 1 is also a management account. In the management account, I have to enable the queuing for the RAM service for our organization. So that's why I selected Go account 1. Now, since I'm sharing the VPC from the second account to the first account, I have to create a resource share. So this is a resource share object for this RAM service, and I'm creating this in the Dev account 2. This is where my shared VPC will be created. Now, I also need to allow certain participant accounts, which will be sharing this VPC. So, the second account where I'm creating the VPC, I'm creating one more resource called RAM_principal association. So here I'm mentioning the AWS account ID for the first account because I want to allow this participant account to share the VPCs from this account. Similarly, I'm creating one resource association. So this is the important configuration. I'm creating that in account 2, and this I'm doing for every subnet which I wanted to share. So since there are 3 public subnets, for every subnet I am creating this resource. Similarly, I have 6 private subnets, 3 for the data plane and 3 for the control plane. So I'm creating these resources again for all the 6 private subnets. So if you notice, I'm creating all of these resources in the second account, the account where I'm creating the shared VPC. Only thing I did in the primary account is enabling the shared access across organization. Everything else is in the second account. Okay. So this is my configuration. So if you look at the versions just for a moment, you will see that I'm using the latest version of the Terraform 1.7.4 at the time of recording this. At the same time, I'm using pretty much latest versions for most of the modules and providers. So let us go ahead and run the script. So we already run the Terraform plan. Now let us run Terraform apply with auto approve. So if you see various resources are created in the second account, it is now sharing the subnets, public subnets and the private subnets. It is creating the VPC resources. Let me pause till this completes. So if you see the Terraform completes the execution, you will see the output here. So let me first copy these outputs into our lab instruction file. Let us analyze this output. So we have the region set up as using one. The dev account 1 is this, we saw that earlier. Dev account 2 is this, where the resources are created, and this is a default security group, and these are the private subnets. So there are 6 subnets, 3 for the control plane, 3 for the data plane, and these are the subnet IDs. Now, if you see the sizes for the private subnets, the first 3 subnets are for the control plane, with size /28, which is 16 IPs. So since there are 3 availability zones, it will be 48 IPs we are reserving for the control plane. Now, the remaining 3 private subnets are for the data plane. This is where the nodes and the pods will be running in the subnet. So /18 means 16,000 IPs. So times 3, 48,000 IPs. This is where the bulk of the IPs will be reserved. Similarly, the private subnets, these are the ARNs, these are the IDs, and the sizes I took is /24. /24 is 256 times 3, so 784 IPs. Now, this many number of IPs may or may not be required based upon the workload. We can decide in the production environment. So this is my shader block. This is a VPC ID, and this is the name. Now let's go to the console and see how these resources are created. Now let me go to my second account. This is my second account where I created the VPC. So if you see, this is my VPC, and let us look at the subnets also. So there are 15 subnets. So 6 of them are from the default subnet. The remaining 9 are created just now. So if you see the subnet name, I'll just sort this based on the name. So CP1, CP private 1, private 2, private 3. Each of them are /28 means 16 IPs, out of which only 11 will be available. Remaining are reserved. Similarly, for DP1, DP private 1 up to 3, we have 16,000 IPs. Then for public 1, 2, 3, we'll be having 256 IPs, around 250 IPs. So these are the subnets we have created, and this is created in the second account. Now, here, let us go to the resource access manager service and see how the configuration looks like. Okay. So here, resource is shared by me and resource is shared with me. So you are sharing this subnet and the VPC with other accounts. So we are creating the resource share. So that means in the second account you will see the resource share object, and these many resources we are sharing, and the principal with whom we are sharing is this. which is the account which we have shared. Okay. Now, if you go to the other one, resources shared with me. So there will not be any because nobody has shared anything with this account. From this account only we are sharing. So we will not say anything here. Now let's go back to the other account console. So in this case, let me, you don't see anything here. So that is because we have to first go to the RAM access manager and see the invitation from the other account to accept the share. So for example, if you see there is one invitation pending, the name of the invitation is this and this is from the other account. So I will simply accept resource share. So the moment you accept this, you will see that the shared resources with me. So there are 9 subnets shared with this account. And one more interesting thing is if I go to the VPC console and see, now you will see the ID. So let me first go to the right and see which is the default VPC, which is not. The first one is the default VPC, second one is not. So that means the newly created VPC is this. Okay. And this ID is same in both accounts. The VPC ID will not change. So if I go to my other account and if I go to the VPC console and search for this particular VPC ID, it is same. So VPC ID will not change across the sharing. And another thing you will notice is owner of this VPC is this. This is the second account, right? So similarly for the subnets also, you will see that there are many subnets shared, 9 subnets shared, and each of the subnet, the owner will be a different account. So if you see the owner, another important thing we have to find out is here the name of the VPC and the subnets are not propagated from the other account. If you look at the primary account where it is created, you see the name of the VPC and the subnets. But in this account where we are sharing, these names are not propagated. Even the tags also not available. So this is an important consideration. So in case if you are trying to use these subnets, somewhere else, for some automation, you will not be able to search this subnet and the VPC the name or the tags because these are not propagated. So some manual effort is required if you want to use these subnets IDs later on. So that we will discuss when we create a EKS cluster using this subnets in this account. We'll be creating the EKS cluster in this account only. Okay. So another thing we'll find out is if you go to the resource access manager and the settings section, you will see that enable sharing with AWS organization is enabled. So this is what we have configured in the Terraform initially because this is the management account for this entire AWS organization. In this management account, we have to enable this. Only then the sharing of the resources will work across the accounts within that organization. This is important to note. So that is the lab with respect to creating a shared VPC in one account and sharing with the other account. In the next lab, we will discuss how to use this shared VPC and create an Amazon EKS cluster and also deploy some test application to test it.